Hello, this is Mr. Miller, and welcome to Lesson 3.1 for Math 9 on using exponents to describe numbers. So let's take a look at some different examples. The first one we've got here, we're asked to write each expression as a power and then evaluate. So 6 times 6 is 6 squared. So the 2 here indicates that there are two factors of 6. And to evaluate, you do 6 times 6, 36. On your calculator, you can do this, 6. And you probably have an x squared button if you have a scientific calculator. For 4 times 4 times 4, this is 4 cubed. And the 3 indicates that there are 1, 2, 3 factors of 4. When I do 4 to the power of 3, this gives me 64. In part C here we have 9 to the power of 5, and that is equal to 59,049. And in the last example here we have 1, 2, 3, 4, 5, 6. So 6 is the exponent on 2. And 2 to the power of 6 is equal to 64. So, a little bit of terminology here. For number 2, we're going to write each expression as a power, then identify the base and the exponent in each power, and then evaluate. So, for the first one, the power is 5 cubed, the base is 5, the exponent is 3, and 5 cubed is 125. In part B, this is 1 to the power of 1, 2, 3, 4, 5, 6, 7. The base is 1, the exponent is 7, and evaluating that, it's just equal to 1. 1 to the power of anything is going to be equal to 1. In this next one we have 1, 2, 3, 4, 5, 6. 7 to the 6, the base is 7, the exponent is 6, and 7 to the power of 6 is equal to 117,649. And the next one we have 305 to the power of 1. The base is 305. The exponent is 1. There's only one factor of 305 there, and its value is 305. And that's all there is to number 2. The next example, we're going to write each power as a repeated multiplication and then evaluate. So the first one is 6 cubed, which means it's 6 times 6 times 6. And so you can either evaluate it as 6 to the power of 3 or 6 times 6 times 6. Either way, you should get 216 as your value. Another way to write repeated multiplication is to use brackets. So here is 2 times 2 times 2 times 2 times 2. And 2 to the power of 5 is equal to 32. Another way to write repeated multiplication is with a dot. So 3 dot 3 dot 3 dot 3. This is also called the dot product. And when you evaluate it, dot's the answer. Get it? Dot. Anywho, next one we've got 10 times 10 times 10 times 10 times 10 times 10. This is an easy one to evaluate because the exponent actually tells you how many zeros there are. So for powers of 10, makes it pretty easy. Just as a double checks, 10 to the power of 6. There you go. Count the zeros. 1, 2, 3, 4, 5, 6. Next one is 4 squared. So 4 times 4, of course, is 16. And 20 squared is 20 times 20, which is equal to 400. Okay, that takes care of that example. Let's move on to the next one. Write each power as a repeated multiplication and then evaluate. So now these are looking at how the negatives get involved. Negative 2 to the power of 4 means it's negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. And that's because of the fact that when you have a negative times a negative, you get a positive. Multiply by a negative again, you get a negative. Multiply by a negative again, now you're back to positive. So as you can see, when the exponent is an even number, you'll end up with a positive answer, and when it's odd, you'll end up with a negative answer. Part B looks a little bit different, and what it means is negative 2 times 2 times 2 times 2. Notice there's only one negative sign there, so the answer is negative 16. It's the opposite of what we had in part A. Then we've got negative 6 times negative 6 times negative 6. So 6 times 6 times 6 is 216, and a negative times a negative times a negative is a negative, but it's the opposite of that, so it's positive 216. And here we have negative 6 times negative 6 times negative 6 times negative 6. And so basically we've got one extra factor of 6 here from what we had last time, so this is 1296. Again, you can double check that by doing 6 to the power of 4. Here we have 5 negatives in a row multiplied, so that makes it negative overall. And again, an odd number of negative factors makes it negative. An even number of negative factors makes it positive. Number 5, we want to complete the table. Take the repeated multiplication, write it in exponential form. This is negative 3 to the power of 4, and its value is 81. Next we have negative 2 to the power of 1, 2, 3, 4, 5. And so negative 2 to the power of 5 is equal to negative 32. Notice we have an odd number of negative factors, so that's why the answer is negative. Here's the exponential form in repeated multiplication. It's going to look like this: negative 6, negative 6, negative 6, negative 6, negative 6. 5 factors of negative 6. And so negative 6 raised to the 5 is equal to negative 7,776. Now the next one is interesting because we have a value here. It's not indicated what the base is, what the exponent is, so this really could be a number of different things. Here's one possibility, very simple possibility, is that it's negative 125 to the power of 1. So that would be just a single factor of negative 125. Of course, it could be negative 5 cubed. In other words, negative 5 times negative 5 times negative 5. Are there other possibilities? I think that pretty much covers it, but if you come up with any creative answers, please let me know. Let's take a look at one last example, and then we'll be done. You can get started on your homework. So for number 6 here, it says that bacteria reproduce by splitting in two. If a single bacteria, that's 1, divides every 20 minutes, how many bacteria will a single bacteria produce after 8 hours? So in exponential form, we start with 1 initially, and we keep multiplying by 2. So 2 to the power of how many 20-minute intervals are there in 8 hours? Well, 8 hours times 60 minutes is equal to 480. So we've got 480 minutes here, and if we divide that by 20, then that means that we have 24 times that we are doubling the number of bacteria. So let's calculate that answer. 2 to the power of 24 is a fairly large number, ends in 216. Before that we've got a 777, and before that we've got 16. So this is 16,777,216. What assumption did I make here? Well, I assumed that no bacteria died, and that there is enough room and or food for the bacteria to continue to grow. Okay? And so that pretty much covers it. Thank you for watching, and have a nice day.